Hi, welcome to the Witches Tech. This is the channel overview. The purpose of this channel is to talk about the technology that is used by Athens area pagans. If you want to know more about Athens area pagans, there's the web address athensareapagans.org. I want to point out that this channel is about technology that is used by pagans, so normal everyday technology that anyone might use just happens to be being used by pagans. I'm not going to be talking about techno-pagan practices. That is, I'm not going to be talking about how you might use technology within your techno-pagan life. I'm not going to say that's never going to happen because this is a pagan channel. Yeah, sure, we'll probably talk about that some, but mostly this is just about straight up tech. While I'm on that subject, we are inclusive. If you have a different faith or no faith at all, or you don't know what your faith is, or you don't care, you're welcome here. If you find something in these videos that is of use to you, that's just awesome. The question you might be asking is, why do the pagans have their own technology channel? And the reason is mostly because of privacy. So a lot of our members are, like, some of them they won't go on Facebook. They're often very afraid of their identity being revealed. I'm in a special situation. I kind of can just be who I am, but a lot of them have really significant and serious privacy concerns. They have a lot of concerns about discrimination. There's still discrimination. You would think not, but yeah, there is. So it's kind of important to us, as much as possible, to own our own data. So we have our own tech so that we can own our own data as much as possible. It's not that we never use Google or Facebook or anything like that, or YouTube. You're probably watching this on YouTube. But we do have spaces that are a little bit more private. The kinds of spaces we have, we have a website, of course, athensareapagans.org. You can see a picture of the website. We use WordPress to make that website happen. This is a Nextcloud instance. This is my dashboard for Nextcloud. We have our own Nextcloud instance. We also have a Matrix Synapse instance. So Matrix and Synapse they're the backend for something that you might use, Slack or Discord. If you use Slack or Discord or even Facebook Messenger, like if you took Facebook Messenger and made it, a lot more featureful or feature rich, this is the backend that you would use to support that interface. Usually we use Element, which you can see the image of with everything redacted. That's an image of Element. We usually use Element as the interface to the Synapse instance, but you don't have to, and I'm getting ahead of myself. In a future video, we will go into all of this in a little bit more detail. All of this, I just noticed the video is shaking. I'll try not to have that happen in the future. Anyway, everything we have here is self-hosted in our own cloud. We use Swarm mode from Docker. It is a Beowulf cluster. That means that it's made up of whatever computers we were able to find wherever we were able to find them for cheap or free and cobble them together into a little cloud. And in fact, it's right back over there. So the computers that you see in that image are over there. That's where the cloud is. So if you want to know how to make your own cloud in, your house, then see more of these videos, I guess. Sort of pointing out Docker as the main thing that we use as our infrastructure, base infrastructure. That's what makes the cloud. There's also Free IT Athens. I want to shout out to them. They're a local organization that repurposes old computers. So they fix them if that's necessary and put an operating system on them and give them a second life. So instead of going to a landfill, they get reused. And most of the computers are from Free IT Athens, and those that aren't are just other members have said, hey, I don't need this computer anymore. Can y'all use it? And gave it to us. So anyway, we're also keeping computers out of the landfill. And if you can build a cloud on shoestrings and bubblegum, why not do it, right? The topic of this channel is mostly going to be systems. before I get to the definition of systems, let's start with the definitions of hardware and software. You probably have a basic idea. My favorite definition of hardware and software is hardware are all the parts of the computer that you can kick, and software are all the parts of the computer that you cannot kick. Systems. The systems are all of the hardware, plus the parts of the software that do not implement directly your business logic. For example, if you have a web page, then displaying content in a browser over the internet, that is your business logic. That's what you're trying to do, is display the content. How you display the content. Do you use WordPress? Which web server do you use? Is it Apache or Nginx or something else? What kind of computers are they on? Or is it in the cloud like at Amazon somewhere? What database do you use in the back end? That's all systems. And then you might also write software to control all of these systems and make them work together. So that software that you write to control the systems and the software in the background and all of the hardware, that's the systems. It's all the stuff you can't see, but it's really important. And that's the main focus of this channel. The range will be really broad. It's going to go from high-level abstract all the way down. So high-level abstract, I mean like enterprise architecture. Archimate is a language for describing enterprise architecture. Behavior-driven development, the solid principles, and you might think of some of these things as being really software relevant, but I promise the same ideas apply kind of everywhere, but certainly also to systems. We'll talk about some design concerns that are slightly higher level, like if you've got storage, and the storage has to be visible to all the parts of your cloud, right? Are you going to use a plain network file system, or do you want to use a distributed file system or something else? How are you going to do that? There might be videos about that sort of level of things. And then we'll also have videos about everyday tasks, like how do you use pipes and redirects on the command line in order to get stuff done easily. Of course, security. Security is a concern. And one of the main reasons that I didn't really do these videos for the longest time is because I was really worried about security. I'm afraid that I'll say something that's going to expose us or make us even more vulnerable than we are. And the fact that the computers in my room over here are running the cloud, it's kind of information altogether right there. But I'm going to try to err on the side of safety. But if I don't teach this stuff, that's also a problem. So if your security is so good that things just fall apart, that's kind of not good. Speaking of things falling apart, we currently have an abduction factor of 1. The abduction factor is the number of people who have to be abducted by aliens before the whole system falls apart and things stop working. There are people who like bus factor, as in how many people have to get hit by a bus before everything falls apart. I don't like that because being hit by a bus is not fun, and there's a chance that being abducted by aliens would be fun. So I prefer abduction factor. Anyway, I am the single point of failure right now. I'm the only one that really knows how everything works, and that's really bad. It's not good at all. It's really bad strategy to have one person who is, kind of central to or so important to an endeavor. So the point here is to try to change that. I want to increase that number from 1 to something higher. And the only thing I could think of to do is to teach the stuff. So here I am. By the way, would you like to intern with us? We do offer internships. You could volunteer too. If you already know the stuff and you just want to come help, oh, thank you. But if you want to intern, thank you. We would love to have you. We've had 3 interns so far, and they've done great work. It's really nice. I think, anyway, it's pretty laid back. Anyway, go to AthensAreaPagans.org/intern if you're interested. So, if you wonder how I know all this and why you might listen to me, I'll get into my full CV later at the end of the video. But my day job is to make molecular modeling services available online. And glycam.org, that's the website where it happens. And I'm sort of manager of a team. Oh, they're an amazing bunch of people. They're so good. Anyway, I manage a team that makes this website happen, and it's wonderful. as a job, and all the stuff that I have to know in order to do that. I mean, that's way more than it takes to put some computers together and make a Docker swarm and have a website or whatever. That's relatively really really easy. I should also point out at this point affiliations that I have and make the usual disclaimers. So if you were to look me up, you would probably find all of this information. I work for the University of Georgia in the Complex Carbohydrate Research Center. And as I mentioned in the last video, our group makes this website, Glycam, glycam.org. Glycam.org and most of the activities in our group are part of a bigger consortium called GlycoMIP. That's the Glycomaterials Innovation Platform. That means we're trying to help accelerate the creation of materials, so mostly nanomaterials, that sort of thing, that are made by glycans or glycotechnology. Carbohydrates, when I say glycans, that means carbohydrate. These are funded by the National Science Foundation, and some of the members of my group, and certainly me for most of my time in the group, and even Glycam Web has in the past been funded by the National Institutes of Health. The AMBER project, that is molecular dynamics software, and I'm on the developers list for AMBER, the AMBER project. These things are all totally separate from what I'm doing here. This is my community service. This is volunteer work. I don't get paid for this. There's no money going on here. There are no resources being used from any of those entities in this. I'm definitely not speaking for any of them. My opinions are mine and definitely not theirs. And in no way do I mean to represent any of those in these videos. I should also point out that I'm not speaking for Athens area pagans. I mean, a little bit I am, as in I'm telling you the tech that's being used by Athens area pagans, but my opinions, to the extent that I express opinions here, will be mine. And I promise you, somewhere in the group, there's somebody who disagrees with me. That's just going to happen. But they all know I'm doing this, and so far they like the idea because they also understand that having an abduction factor of 1 is a bad thing, and we got to do something about this. So, moving along. The videos. I plan to have videos happen, say, once a month, but this is an all-volunteer organization. No one in this organization gets paid, so things are going to happen whenever they can happen. I hope that in the future it won't just be me making videos, although I'll probably make a lot of them, or perhaps most of them, at least at the start. So monthly-ish, you'll get a video. The video quality. It's going to be whatever I can do just easily. I don't have a lot of time to make really fancy videos. I spent the last couple of months sort of making this setup so that I have something that I can do relatively quickly and easily, generally in one take. I'm not going to have time to do a lot of video editing. I know how to edit video. That's how I know how long it takes. I use Kdenlive to edit video, and if I need to massage audio, I use Audacity for the most part. I do, so I know what I'm doing. I just don't want to expect mistakes, flubs in what I say, or, the cat might walk past the video, who knows what's going to happen. Profanity, I cuss, just happens. And occasionally I might drop into a deep South accent, and you won't be able to understand a word I say. And so I'm going to have to be all right. Having said that, if you would like to help with the video quality, if you know how to do that, that's great. If you would like to intern to learn more about making videos, that's all great. We could use the help. Moving on to my CV. So my first real contact with a computer was with a TRS-80. So TRS stands for Tandy Radio Shack, but this is colloquially known as Trash 80. The people at Tandy Radio Shack hated that people called them Trash 80, but that didn't stop people from buying and using them, so, whatever. It was running BASIC. I used the BASIC programming language. That's the name of the programming language that I used. The image you see may not be the actual computer that I used. I can't remember exactly what it looked like. I saw it for like 2 or 3 days while I was visiting my dad on vacation. I don't remember exactly what it was. And then there's an attribution for user Bilby at Wikipedia, Wikimedia, and I have attributed, and you can follow that link to learn all about the licenses. So for some reason, my brother had one of these computers, and I don't remember why, and I don't think I knew or cared at the time. And for some reason, they let me play with it. So I read the instructions, and I read a little program. It was a simple little program. I was 13. Did I mention that? I was young. So I made a little program that would talk to you and ask you what your name is and ask you what your favorite color is. And it would either agree with you or it would say, oh, that's a really nice color, but I prefer this other color or whatever. And from that, my takeaway was that computers are interesting toys and otherwise kind of not all that useful. And I stayed there with that opinion for a really long time until I was working on my PhD. So this is in the early 90s, early to mid 90s, actually. And then I realized that you could model atoms and molecules on computers, and suddenly I saw the reason for their existence and became interested in them. So during my PhD, I wanted to do some simulations of atoms and molecules. And I was using the cluster in the physics department. And so I'd have to log on to the cluster in the physics department and write my scripts and test my scripts. And then I would have to submit a job and I would have to wait in line behind all the other graduate students in the physics department who were doing their jobs. And eventually my job would run and maybe it would work or it wouldn't work. And it might take, a whole day just to figure out if it worked. And a friend of mine said, you can install this thing called Linux on your computer. And it was Slackware Linux version 0.9 point something or another. It's been a while. The image you see, those are the actual installation disks that I used to install Linux on the computer. I still have them. I keep them in a display case, and I kept having to save them from my mother because she thought they were ugly and she couldn't understand why I was keeping them. But anyway, um, the that operating system allowed me to not just figure out if things work, but I actually just ran all the simulations on that computer because the speed of the computer was similar to the speed of one of the computers in the physics department. But instead of having to wait in queue for all the other graduate students, I could just run programs 24/7 in my bedroom. And that's what I did. And so because of this flexibility of Linux, I just learned a whole lot about how it works because, there were always more things that I wanted to do. And almost all of that was driven by science or wanting to teach or something like that. So just to give you an idea what I was doing, not at first, what you're seeing here was something a little bit later. So this probably happened in the later 90s, early aughts. I was working on emissions that might happen out in outer space. So you see pictures of, nebulae or whatever, the ionospheres of planets, the sorts of reactions that happen there. That's what I was studying. So the image you see in the middle, sort of there, little circle thing, that's a photograph of the reactions or one of the reactions that I studied. And then the graph you see below it has the green lines. Those are the actual spectrum from the reaction that you see in the photograph above. So the spectrum that was taken using, equipment. And then the red lines are my simulation of that spectrum. And I was really amazed with the agreement between those two. And it took so much work to make that happen. That was not trivial at all, but it did turn out really good in the end. And the whole reason I did it was so that I could figure out the temperature at which certain products of the reaction were produced. And woohoo, I got a PhD. So the point there is that I didn't even really start paying attention to computers until I was in graduate school. So I've been self-taught almost completely. I took a Fortran class in undergrad and a Unix and C class for a quarter in graduate school. But other than that, it's been self-taught. Like I taught myself C in order to write the program that I talked about in the last slide. Everything I learned was on a need-to-know basis. So computing has always been a means to an end for me. That means that I have atypical knowledge patterns. So I didn't go to a school and I didn't learn a standard canon. And that means that as you're watching these videos, I'm going to know what I know. I might not use all the words that you're used to using. I might use different words. I might use words that I had to make up because I didn't know what the word was for whatever I was doing. That just happens. So just letting you know that ahead of time. If you think that I need to know a word, leave a comment and I will go look that word up. I will appreciate it. My current job, as I mentioned, computational chemistry, make a website happen. My specialty is carbohydrates, as mentioned earlier. I am the enterprise architect for the website, GlycamWeb at glycam.org. Enterprise architect means that I figure out all the components you need to make that needs to happen to make this work, and how they interact with each other, and like what things to use. Like we need to use Python programming language here and C++ here, and we need to use Django for our web framework and whatever else. And I have, how do I make EITS, the computing people or the security people or the grant people or the graduate students, how do I make all of these people happy? How do I make all of these things happen and keep all of the stakeholders happy? That's enterprise architecture. For Athens area pagans, I still think of myself as a glorified sysadmin, but it's also enterprise architecture. Here, I figure out where the computers go, how they connect to each other, etc. So anyway, thank you, and subscribe, like the video if you like the video, subscribe if you like the ideas that might be here and you want to see more videos, and of course leave a comment if you got one. I really appreciate your watching. I hope you get something out of these videos. And today's rubber ducky is unicorn duck. This is not the sort of unicorn that gets billions of dollars from startup funds. There's nowhere near that sort of money here. This is, just someone to talk to